So next, let's talk about how we remove a doubly linked list from memory. So for this algorithm, we'll call it clear because we're going to clear the linked list. And there's a few things that we have to make sure happen. One is that both the tail and the head reference are both pointing to null. And two, we have to make sure that all the nodes leave memory. And in Python or Java, this is going to be really simple because all we have to do is set the tail reference and the head reference to null, and then the garbage collector will do the rest. Similarly for Python. Now we're going to need to have the tail reference and the head reference in scope because we need to be able to update them to null, both of them to be null. So if we're talking about Python or Java, we simply set the tail reference to null, or in the case of Python, none. For the head reference, we set it to null as well. So both those scenarios, garbage collector takes care of it. Fantastic. Now, if we're dealing with, say, C++, then it becomes just a wee bit more complicated, but not by much. This is going to be very similar to what we did in a linked list, a singly linked list. So we're still going to need to have the tail and the head pointers in memory. So this is for Java and Python, and this would be for C++. So what are we going to do? We're going to have to go node by node by node, deleting each one in turn. And we're going to have to make sure that our tail and our head are left pointing to null pointer. So what are we going to do? We will use our head reference to do the traversal, because at the end, we want this thing to be null anyway. So long as it is not pointing to null, so long as there is a node it's pointing at, what are we going to do? We are going to grab that head node, then we're going to advance that head reference, that head pointer, and then we're going to delete the node. Delete that node, whose memory address is in pointer P. Now once this is done, all the nodes are deleted from memory. The head pointer is pointing to null, but our tail pointer is pointing to an invalid memory location. So we have to update it as well. So that'll be the last thing we do. We'll set it to null pointer. Okay, that's it for our clear algorithm. Now let's trace to this code to make sure that it works. So let's say that we've got a empty list. It's going to look like that. That's scenario one. So we run our algorithm while head pointer is not equal to null. Well, that's false. So this while loop just completely gets skipped. Then we overwrite the tail pointer with null pointer, and that's just fine. We haven't tried to delete anything that we can't delete, and our linked list is left in a valid state. Now let's say that we had a non-empty doubly linked list. So maybe something that looks like this. Are we going to handle it okay with our algorithm? Well, we're going to trace through our algorithm and see. So while head not null, that is true. So what do? We're going to create pointer P, and we're going to point that at the head node, and then we're going to advance our head pointer to the next node. We're overriding the contents of the head pointer with the head node's pointer. So that's going to change our picture to look like this. And then we're safe to delete P, delete that head node. So that leaves memory. Now temporarily, our P pointer is pointing to an invalid memory location. But that's okay because we're going to go to the top of the loop and we're going to check to see if the head pointer is pointing to null. Again, it's not. So we're going to update our P to point to what the head is pointing to, what the head pointer is pointing to. And then we update our head pointer to point to the next node. And then we're free to delete the node that P is pointing to. So that leaves memory. While head is not null, and it's not because it's got the memory address of the last node, we're going to update our P pointer to point to what the head pointer is pointing to. Then we update our head pointer to point to head next, which is going to be null. Then we delete our node by deleting P. That leaves memory. And then we go to the top of our loop. Well, head not null. Well, in that case, this case now, that's false. So our loop is done. Our loop is done. And we have head pointing to null, which is what we want. Now, P pointer is a local variable. So it's going to leave once our algorithm completes. And once the loop's done, what's the next thing that happens? We overwrite the contents of T of our tail pointer, which was pointing to what? An invalid memory location once we delete the last node, right? So that's why we have to update that, have it point to null. So that's what we do by assigning null to our tail pointer. So are we with an empty list? Yes, we are. Are there any nodes left in memory? No, there isn't. So our algorithm works. Now, what is the performance of both of these versions of the algorithm? So for our Java Python algorithm, we've got two operations. That's it. Big O2, which we can rewrite as big O of 1. Constant time algorithm, because the garbage collector is going to do all the work for us. Now for C++, what do we have? We have to go through and delete each node. So there's going to be n nodes in the list. And for each one of those nodes, we have to do a check right here. That's one operation. We have to do an assignment to P. That's another operation. We have to advance our head pointer. That's another operation. And then we have to delete a node. That's another operation. So that is 1, 2, 3, 4 operations for every node. And then once the head pointer is pointing to null, we also have a test for that too, right? So that's 4n plus 1. And then at the very, very, very end, we have to update our tail pointer to point to null. So that's one more operation. So what we have is an algorithm that is 4n plus 2, big O. But again, for really large numbers, who cares about the plus 2? And 4 times infinity is still infinity, so we can get rid of the 4. So this is a big O of n algorithm for C++. So a lot slower when you don't have that garbage collector helping you out.